Let's look at definite integrals now. The definition of a definite integral is if f is defined on a closed interval and the limit as the partition goes to 0 of the sum as I goes from 1 to n of f c sub I delta I exists, then we say f is integrable, and the limit denoted by this limit as the partition goes to 0 of the sum of f c sub I delta x sub I is the integral. It's the definite integral from a to b of f of x dx. Now I want you to notice a and b are your limits of integration. The summation sign we replace with this big S. We call it the integral sign. Fc sub I becomes f of x, and delta x sub I, which is telling us the widths of our rectangles, becomes dx. Now there is a theorem that says continuity implies integrability, so as long as we can show that a function is continuous, then we can use a definition and integrate it. Let's use this as an example. Let's look at the integral from -2 to 1 of 2x dx. Now, in this case, our lower limit is -2, our upper limit is 1, the function is 2x, and I'm taking my rectangles in dx. So, the first thing I want to do is define delta x of I. And I want it to be a regular partition. And now we want dx to be positive. So if I look at b minus a over n, that is -2 minus 1 over n. So that's -3 over n. And we can do that. But for convenience sake, let's make delta x positive and make delta x equal 3 over n instead of the negative. Now we can choose C sub I any way we like, but let's go back to the regular partition that we used before. All right, and let C sub I equal A plus I delta X. Now here I do have to keep that negative sign. So this is -2 plus, now it's going to be I times 3 over n. So I can say the definite integral from -2 to 1 of 2 of x dx is equal to the limit as the partition, goes to 0 of f evaluated at c sub I delta x sub I. Now, I haven't told you what FCI is here. F is this part right here. So f of x is 2x. So f c sub I is, let's see, I'm kind of run out of room here. It's going to be 2 times -2 plus 3i over n. And you don't have to write this separately. You can come down here and put it, that's fine. So remember the limit as the partition goes to 0 is the same thing as the limit as n approaches infinity of, oh, I forgot my sum, didn't I? Sum I goes from 1 to n. So this is a limit as n approaches infinity of the sum I goes from 1 to n of f c sub I delta x sub I. Now I know it seems routine, but you do have to write both of those down. And now we're going to plug in, or we're going to substitute in. This is the limit as n goes to infinity. I'm kind of at the bottom of my pad here, so let me move up. Of the sum as I goes from 1 to n. Now f c sub I is 2 times -2 plus 3i over n times delta x sub I, and remember delta x sub I is 3 over n. Now let's multiply this out. It's the limit as n approaches infinity, and I'm going to pull 6 over n out front. I'm going to pull it outside of the sum. Sum as I goes from 1 to n of -2 plus 3i over n. So this is the limit as n approaches infinity of 6 over n times. Now this is going to be negative 2n plus 3 over n. The sum of I, you remember, is n times n plus 1, quantity over 2. Make sure I get all my brackets there. So if I multiply this all out before I take my limit, this is a limit as n approaches infinity of, I'm going to have some stuff cancel here, negative 12 plus 9 plus 9 over n. So the limit becomes negative 12 plus 9, or negative 3. Now, the definite integral does not have to be positive. And if we come up here and we look and we find the area of this triangle, it will be negative because, let's look at this. The area of a triangle is 1/2 base times height. So this base is negative 2. So the area of this one is 1/2. The base is negative 2. And the height here at negative, well, the base is 2 and the height is, the base is 2 and the height is negative, excuse me. It's negative 4. So this area right here is negative 4. Now if we look at A2 is 1/2. The base here is 1 and the height is 2. So A2 is 1. So A1 plus A2 gives me the total area, negative 4 plus 1, or negative 3. So now we can define area by if f is continuous and non-negative. We have to be careful with the negatives here. On a closed interval, then the area of the region bounded by the graph is given by the integral from a to b of f of x dx. And as we just saw, any area beneath the integral, we're going to get a negative area.